My name is Louise Poubel. I'm a software engineer at the Open Source Robotics Foundation. We are a company in Mountain View, a nonprofit, and we do open source software for robots, both software that runs on the robots and tools that help people develop software for robots. Today I'll be talking about Gazebo, which is a robotics simulator. And I work in the core development team for Gazebo. And I'll be focusing on how we are trying to welcome different types of users to use the simulator. So I'm just going to talk about the things that we have been trying. I'm not claiming to have all the answers. Actually, I might not have any answers. But I'm just going to tell you what we, as a small development team with a complex project and a diverse group of users, what we are doing to try to please all these different users. So for those people that, like, who here knows what Gazebo is? Okay, 2 people out of 7. So I'll give you a little intro for people to have an idea of what users are using Gazebo for. So you can simulate all types of robots in Gazebo, from industrial arms to mobile robots with wheels and robots with legs, biped robots, humanoids with a lot of joints, swarms of robots, so you can have like hundreds of robots in the same simulation, flying robots, fixed wing, or drones, underwater robots as well, some modular robots, diverse environments, indoor, outdoor. There's a wide range of sensors that you can put on your robots. There is integration with ROS, the robot operating system, as well. Integration with different hardware like VR sets and controllers. We host a lot of competitions inside Gazebo, and I'll talk about them a little bit later. And it's widely used in education and prototyping. So you simulate something and then you make it in the real life. So this is a quick intro of what people were doing with Gazebo. So like going more into the details, what is Gazebo composed of? What is a robotic simulator in general composed of? Many people associate it more to the physics side, and of course this is a component. It calculates how your robot is going to interact with the real world. And we want this to be as close as possible to how your robot would be in the real world. So we need very realistic physics. But there is also realistic sensor data generation. So your real robot is going to have cameras, is going to have LiDAR, and we have to, the simulator generates this data just like the real world would generate that data for your real robot. There's also the graphical user interface, which is this thing that you're seeing here. By the way, if I haven't mentioned it before, the whole simulation is being done inside the simulator, the whole presentation, because I like to do these presentations like this. I think it's fun. So the graphical interface is this, and it's good for you to observe your robot as your robot is trying to do something, and it's good for you to interact with your simulation, just like you would in the real life. You would move something for the robot to track. You can move something in simulation. And also the graphical interface is used for you to build your world, your simulation environment. There are interfaces. So this is how people they have their code running in their robot, and they want to plug that into the robot that is inside the simulation. So what kind of APIs, what kind of interfaces we provide to our users so they can do this? Something like if you have a robot that is running ROS, the robot operating system, how do you use that same code also in simulation? And finally, there is the cloud component, which is there's 2 parts of it: running the simulation on the cloud and also hosting simulation resources on the cloud that many users can share and use in their simulations. So some statistics about Gazebo, just to give you some context of the order of magnitude of the project. It's been around for 15 years. It's been open source and free since the very beginning. We have about 1,000 downloads per month, but with open source, it's always hard to really measure how many users you have. There is a lot of lines of code, and I have some statistics there about testing, but it's important to notice that this is all statistics from one of our repositories, the central one. So there is a lot of other things, other libraries around Gazebo that I didn't count here, and there's stuff like documentation and all. So the numbers are a little bit, this is very conservative, but it's good for you to have an idea of the order of magnitude. So for example, we have 100 contributors, it's not 10,000, but it's probably more than this if you count the big scheme of things. Some of our dependencies. So the one on the top, SD format, is the simulation description format that we use to describe the simulation. So it's an XML format. This is how people describe their worlds, everything from how it looks like to how it's going to behave physically. And then in the second row, we have the 4 different physics engines that we support. So we have an abstraction layer on top of these different physics engines, and at runtime, you can choose to run your world file with either one of them that you would prefer, and depending on your use case, depending on how complex your robot is, or like the number of robots and the kind of interactions that you require, one physics engine or the other might be best. So we offer all these options for you. So they are Open Dynamics Engine, Bullet, Dart, and SimBody. Then down here we have Ogre, which is the rendering, what we use for rendering. Everything that you're seeing here in the 3D view is done using Ogre. We use Qt for the graphical user interface itself. This is all, by the way, C++. Gazebo is written in C++. So we use protobuf, Google Protocol buffers for inter-process communication. And finally, ignition libraries are actually libraries that used to be part of Gazebo, and they used to be inside Gazebo. And other projects wanted to use them, and we wanted to make Gazebo itself smaller, more modular. So we are breaking things out of Gazebo and putting in libraries that we call ignition something. So there's ignition math, ignition transport, ignition physics in the future, ignition rendering, and so on. For the cloud, what we are doing, we have a couple of different projects. The first one is CloudSim, to run the simulations on the cloud, as I mentioned earlier. Another project is the Prop Shop, which is a place for users to host their simulation resources online. And this goes from the SDF files, the model descriptions of your world, until the meshes, until the plugins that you're running on your models, and everything that is related to your simulation. And we also have a web and mobile web client. So if you're running in the cloud, for example, you can visualize your simulation on your phone. Okay, so I gave you a general overview of what Gazebo is and what it can do, but what are people using Gazebo for, right? Like, just looking at it like this, if you're not from the field, if you're not from robotics, you just think, well, this is a very lame video game. But, people are using it to actually try out different robotics algorithms. And people in the academia and people doing R&D in companies, they are trying out new algorithms in robots, and it might be very expensive to do it in a real robot. You might have one robot for a team of a lot of people. It might be very expensive to bring the robot up and down, or just very risky for you to try to make your $1 million humanoid robot jump, and then it fails, and then you broke, your robot. So you try these things in simulation. It's also used for prototyping, so creating new robots before they exist. It's used a lot in education. Professors in universities just give homework to students inside the simulation. Each student has their own simulation. It's used a lot in competitions. Right now, we're actually hosting 2 different competitions that I will mention later. People like simulation for competitions because it gives every single team the same controlled environment, different from when you go outside, maybe the sun is hitting different when each team is competing and things like this. It's a very controlled environment, which is good to be fair. And finally, like continuous integration. Companies that are shipping robots They want to make sure that the changes they make in their code are not going to break anything and are not going to make the robot behave differently in the world. So they have these simulated worlds, and they pass that through continuous integration every time they are making changes in their code. These are some of the main use cases for Gazebo. OK, so this is what people are doing with Gazebo, but who are these people? Who are these people who are sitting in front of the keyboard and looking at these 3D worlds and using them? So I put together here a little graph of some of the skills that someone would need to have to kind of use Gazebo, right? The set of skills that you need. So for example, here on the top, this here represents software integration. It's those people who have the for example, command line skills, and they have a lot of networking knowledge. They can get different pieces of software and make them work together very well. This is one skill. Another skill is C++. This one here is C++, because Gazebo itself is written in C++, and all our plugins are in C++, which is a hard language. And so it is a skill that helps you a lot. Another skill here, this one represents programming in general. So maybe you're not a C++ expert, but you're an expert on something else. Maybe you're a mechanical engineer who does MATLAB and writes these beautiful algorithms, but you don't know C++. So this is the skill you would have. This down here is mechanics. So these are the people who really have the knowledge to fine-tune their simulation, to choose the right surface parameters, to make contact work right, the inertia parameters for your robot. They have this mechanical skill. This one here is 3D modeling. So these people know their CAD programs. They can create 3D shapes and compelling models of objects and of the robot itself. And finally, this one here is rendering. With more and more cameras being used in robots, we need the simulation to look as realistic as possible. So people with skills in rendering and computer graphics are really needed for the simulator when using the simulator, depending on the kind of algorithms that you're trying. If you're doing computer vision and things like this, rendering really plays a part. So let's take a look at one user, right? This user here is a user that knows a lot of C++. They're pretty good with their integration. They know Linux. They're comfortable with the command line. They are very good with algorithms, but they don't know as much mechanics. And they can do some rendering, but it's not their field of expertise. So let's take a look at another user. This user here is completely different. They are very good at mechanics. They know their algorithms, but maybe they do Python. They don't know C++. And they can really make precise parts in CAD. They really know what they're doing when they are 3D modeling things. So it's another user, but it's totally a valid user that is using our simulator. Another user here is a user who knows a lot of their rendering. They can make, it's the people who made this water, for example. I didn't make this. I don't have this skill. I just got it from one of our users that made it and put it open source. So they are the ones who can really make the simulation realistic. So the point here is that we have all these different users, and how can we make all of them comfortable? How can we make the mechanical engineer make the most of the simulation, even though they don't have the skills of software integration and of C++? And how can we make the C++ people comfortable to fine-tune their models mechanically and make sure that they are not going to explode in simulation? It's a big challenge because nobody knows everything. Nobody is a complete power user, right? So some of the things we're doing. The first thing that I think really counts for this is to be open source. We're in an open source conference, so I think it's not news to anybody here. But I think it's very important to be open source because this encourages everybody who's building on top of our software to also release their code as open source. So it's not mandatory, but we encourage them to do so. And this means that there's a lot of content out there made by different groups in different universities around the world, different companies, and they can take advantage of each other's field of expertise. So for example, here we have this robot's called Baxter. It's made by Rethink Robotics. And it's a real robot. It's a company that is shipping this robot, and they use Gazebo as to simulate the robot. And they made the simulation available to everybody online. So if you're coming into simulation and you want to simulate your industrial arm, but you're not very good with the parameters, you don't know what to choose, you can take a look at their files and pick up the kinds of parameters that they chose there. Another example here, it's the UUV simulator group. These are the people actually who I took this water from. So they're doing underwater simulation, and they have these very good realistic worlds, and they have a lot of nice parameters, like to control the buoyancy of the robot and so on. Another group here is Robotics. It's a company in Spain. And what they did here, they integrated OpenAI with ROS, with Gazebo, and they just made that available. So if you're not a very good integrator, but you want to do some machine learning, some reinforcement learning using OpenAI in robotics, you can use what they have done. So you can leverage off their expertise. Another thing that we're doing is we host tutorials online, like most projects do. And our approach to it is we have our own website where we offer categorized tutorials. They're usually quite short and self-contained. And we also offer guided tutorials. So this is not, it's something in between a public wiki that everybody can edit or a private wiki where only a team can edit. This is actually hosted in a Bitbucket repository. So it has to be peer reviewed, but anybody in the community is encouraged to contribute and add tutorials to the website and fix tutorials that might have problems. So whenever you click on a tutorial, you have an edit button that takes you to the source code, and you can edit it right there. And also here on the left, we have a series of guided tutorials. So these are the people who just got to Gazebo and you don't know where to start from. You don't even know what to look for. So the first section is for beginners. It's doing everything with the graphical user interface. So you don't need to know any programming. You're just going to go through the process of creating a very simple mobile robot, putting a sensor on it, and putting a plugin that is going to make it follow the first thing that it says in front of it. All just clicking, just using the graphical user interface. The intermediate tutorials is for people who are more comfortable programming, more comfortable doing some integration. So this is going to teach you how to make a sensor and make your whole new sensor for Gazebo and integrate that with ROS and just have that simulation there. So this has a higher level. And the last one is how to actually contribute to Gazebo, to how to be a developer. Since it's an open source project, how do you contribute back? So we have some instructions on that too. So I'm not going to go into detail on how to do documentation. I'm definitely not an expert, and there have been great talks in this conference so far about documentation, and So the only thing that I want to say is that when you want to make sure, when you don't know who your users are exactly, don't assume they know everything and list every single step. It's a recipe, right? So this is a step this is an example from one of our tutorials, and you can see that it says make a directory. Go into that directory, run this, And I feel like I need to mention this because I've seen projects where people say, install instructions, clone this repository, and run CMake. It's like, what? And then you ask, how do I run CMake? And they give you a link to CMake. It's like, no, I don't need to know CMake, right? If you just run CMake and make, you're done. You don't need to learn about what CMake is. Just make it easier for people. Give all these instructions and let the user, if the user knows what CMake is, if they know how to make directories and stuff, they're going to understand what you're doing there and adapt to their needs, right? But if they don't, you're just giving them the nice, quick start entry point without making them think and try to research by themselves. This helped me a lot. When I started contributing to Gazebo, I could just follow these recipes, and I've been working with it for 3 years, and only recently I'm starting to understand what CMake does. So like, it's not necessary for every single person. The people who are doing infrastructure, sure, they need to understand what it does, but in such a big software, there's so much places for people to do different stuff. Don't focus on the little things. Another thing is giving users different tools. So in the beginning of time, this is in kind of chronological order, from left to right. So in the beginning of time, we used to, this is how you had to describe your robots in Gazebo. You had to write an XML file and tweak all the parameters and then drag that model into the simulation. And so there was some back and forth into this text format, and this was like the standard procedure until Gazebo like 6. Currently we are on Gazebo 8. I'm running Gazebo 8 here. The latest LTS is 7, but I'm running 8, and Gazebo 9 is coming in January. But anyways, so this was the standard way of making a model. And this is already a barrier for a lot of people who are not used to just editing text files back and forth. So we created a graphical user interface where you can edit models in the simulation. You can create from simple models to more complex models if you have, we don't have a full CAD program, but if you're that person who knows your CAD tools and you did your CAD software in SolidWorks or somewhere else, you can import them and put them in the simulation without touching any text files, any configuration files. And a lot of people say, oh, but now you're catering for the beginners. How about the power users that like to edit their text files? We're still supporting the text files. Like, don't abandon your power users because you want to cater for the newcomers as well, right? So, for example, another thing that we started doing is we're starting to release models with templates, right? Like where you can parameterize your models, and this is a step on top of just writing the plain file. And this came after we did the graphical interface. It's not like we are just choosing to cater for one user. And I see projects out there that they say, oh, now we need to, it's easier to do with the graphical interface, let's do just this. No, because there are different users, different needs. So let me see, how am I with my time? I have some time, so let me show you a simple example of the model editor. So I just right-click on this slide, which is a model, and I'm in the model editor. You can see that there's a collision shape that is slightly bigger, so it doesn't fall on the floor because it's really thin. What I'm going to do is I'll pull this here, and I'll put a cylinder here. I'm just going to attach a cylinder to it to make kind of like a pendulum. It's going to be something not very exciting, but it's just for you to have an idea of what the tool is capable of. So here, I place this here. Let's place it in front of the slide. Okay, and it's a little bit long. Let's make it shorter. Okay, so for example, here, if you double click, you can set every single physical parameter or visual parameter for your model, right? You can choose the color, you can choose a lot of different details, but we don't require you to know all of these things. One thing that people don't know very well is, if you're not a mechanical engineer, is how to inertia matrices, how do they work, right? So one thing that we do is, you can choose materials. Okay, this is wood, and we populate some of the stuff for you already. So you press OK, let's make a joint from here to here. So, again, here the y-axis is the green one, and let's put this a little bit higher. There you go. So we just created a really simple pendulum. Let's save. And we're back into the simulation. Okay, so it's paused, and now when I play again, it's there. So, it's very simple for you to just tie things together and see how it works in the physics. You can go back into the model editor and change the length, change the material, and see how things are behaving, all without touching code. But if you do want to touch the SDF file, this saved an SDF file. For example, if you created a whole robot and then you forgot to change the material and now everything is gray and you want them to be blue and you don't want to click to make everything blue, just go in that file and search and replace gray with blue. And that's going to work, right? So you can do a combination. Yep.
Yeah, is that perpetual? Or is that going to stop eventually?
I didn't put any friction in the joint, so yeah, so it's just going to stay there. Yeah. The friction and damping in the joint, you can do that to lose some energy. Another thing we do is provide users with a lot of examples that we host ourselves. So I talked earlier about contributors hosting their examples, but we also offer some reference examples, which are nice for users to go and pick in little parameters and copy and paste, basically, right? So we have an online model database that is hosted in a repository, and we're in the process of moving that to a proper website with a nice REST API that you can just pick models very quickly. And we host plugins as well. So this thing blinking here, this is running a plugin that ships with Gazebo, and you can put in your models for them to blink. This is a sensor. This is a ray sensor. That also comes in the database, and you can insert anything directly on the GUI from the database. So, for example, all these models listed here, they are available online, and you can just choose them by name. We're in the process of making this prettier with thumbnails and stuff. But for example, this is a robot by NASA, and let me place it here. So. Play, there you go. So you just picked a model from the online model database, and you're simulating and you're playing with it. And you can use it to train your robotics skills. Another tool that we have is a forum, which is good for people to put different users together, and they can learn from each other's experiences, and it also relieves some of the weight on us, the core development team, to solve every single question if it's, for example, just in an issue tracker, right? And the format that we do this is more of a questions answers website. So we have right now about 3,000 questions, and it's good to see users just coming and helping out each other and sharing their experiences, because sometimes even we learn from our users. Another good rule for you to be able to cater for your users is to be on your users' shoes. So it's the eat your own dog food, drink your own champagne kind of thing. And we try to do this a lot. We try to take projects which make us use our tools so we can be in the place of the users. And these are some of the projects that we have done before, so just quickly going over them. This is the DARPA Robotics Challenge. This was a competition for humanoid robots. This was actually the first competition that really gave a lot of funding and a lot of gas for Gazebo to be developed. And so this was a competition with real robots, but before, to be qualified, teams had to compete in a virtual competition inside the simulator. And the teams that were best placed in the simulation competition got a real robot to compete in the physical competition. Haptics is a project that we did to simulate prosthetic hands. So while we were doing the DARPA Robotics Challenge, Gazebo became very good at simulating complex multi-joint robots. With haptics, we became very good at simulating grasping. We added a lot of grasping parameters. So it's good because as you are put in the place, like if someone asked us before here, can Gazebo do grasping? And you're like, oh, you can put some links together and you can grasp. But then when we try it ourselves, we see, well, okay, we need some more parameters, you know, and it's good because you put yourself in the place of the user. We've been working closely with the RoboCup community. Gazebo is not the official simulator for RoboCup, but we have been working with the community to adapt to their needs and to give them a more realistic simulation. This one is very cool. I don't know if you know about the first robotics competition. It's a competition for high school students that happens in the physical world. And I think from 2015, Gazebo started being in the official kits that they give to the users, to the high school students. So we need to make this tool useful and easy to use by high school students, right? And one cool thing that we did in the company was when we released the simulation, we stopped the whole company for a week and we divided ourselves in teams and we had to compete against each other on the simulation. And the first couple of days, everybody had to use only the graphical interface to make their robots. And then we let people do like their thing. So it was very cool. These robots are robots that we made at the company. And we learned a lot in the process, seeing it from the point of view of our users. SASC is a competition that just finished. It was playing tag with like 2 teams of drones. And they are actually blown up here because when they're the real size, you can barely see them because they're so tiny and so far apart. ARIAC is a competition that is happening right now. The finals just opened. It's for industrial robots. There's stuff coming in the conveyor belts. So you have to pick and place them very quickly. There's a lot of perception involved. And finally, this NASA Space Robotics Challenge. This is also happening right now. The finals are in June. The finals are going to be, it's very similar to the DARPA Robotics Challenge, but this one is on Mars. And the teams will compete in simulation in the cloud. Controlling this robot here called Valkyrie to do tasks on Mars. But this time, they're not going to get a robot to go to Mars and compete for it in the finals, unfortunately. Another great way for you to get in touch with different users' needs is to actually mentor new users, new contributors, to be in touch with your community. So there are 2 great programs for open source projects. One is Outreachy, which is, I actually was an Outreachy student, and that's how I got involved with Gazebo. And this is a program for women and other underrepresented groups to help for you to participate in open source. And the cool thing about Outreachy is that you don't need to be a student. So like I had graduated already, and I could participate. So it's very cool, and you can work remotely. And Google Summer of Code is another one that is open for everybody, but you have to be a student. And it's also like paid remote work to work on open source. And we have had several interns for both of these programs. I was one of them, and I've mentored interns, and it's always a great opportunity for you to see problems in your documentation. Are your new contributors being able to contribute, or are they getting lost? And problems in the tools themselves, like we don't use the graphical interface much. Is it easy to use? Is it reflecting the everything that we have? So it's a great way to be in touch with these newcomers. So yeah, the point that I wanted to give on this talk is just that there's room for everyone. I'm sure that each project is different. Some projects are very focused on one user group, but a project like Gazebo really has different users and different people who really want to use. They might not be users yet, but they would really profit from using the simulator. So there's room for everyone. I think it's really worth it, even if you're a small team like us, to try to focus your development onto welcoming all these different people. I think I talked too fast because I just got to the end of my slides. So yeah, thank you for being here. This is gazebosim.org is our website. I'm on Twitter too. This QR code takes you to the source code of the presentation if you want to play it at home. And this is our team at the Open Source Robotics Foundation. So thank you. And yeah, I have 10 minutes if anybody has questions or comments, or if you just want to go away, it's okay too. Oh, yeah, sure.
Do you think there will be any Python bindings for this stuff in the future?
Yeah, the question is about Python bindings. I've seen a project called PyGazebo where people were using Python to, yeah, it's not, I've never used it, but there are people using it out there. And if you are using the robot operating system, like ROS has bindings for every language that you can imagine. So you can use Python with ROS and control your robot with ROS inside Gazebo and using Python or MATLAB or Lisp or whatever you're into, JavaScript. Yeah. Yeah.
This robotics foundation, is it, like, what is the global presence like that? Is there any other countries that are also contributing to this?
The robotics competitions?
Yeah, robotics foundation.
The Open Source Robotics Foundation. We are based in California, in the United States, but our tools are used by people all around the world. Like, for example, one of the goals we have for Gazebo is that the next version we support multiple languages, because we don't support that yet. But yes, we have our team at OSRF is very diverse. Like, I'm Brazilian, and we have people from other countries as well, and basically every continent. Oh yes, we have a lot of contribution with companies. For example, Toyota just gave us a big donation to make Gazebo and ROS best for the kind of things that they are interested in and to work closely together with them. But yeah, there is a lot of other companies that help us in different ways and that unite forces with us. Sorry? With universities. Yeah, we work with universities in different projects. Like we do a lot of projects with the government, and sometimes we make partnerships with universities to apply for these grants together, for example. And sometimes we just there is a lot of people in the academia using our tools. So they're the ones active in the issue trackers, making pull requests, making conference talks about our stuff. So we work closely together with them.
So I'm curious about robotics in agriculture. So is
Mm-hmm.
there any efforts happening there?
Yeah. So robotics in agriculture. In the video that I showed earlier, there was some simulation of some trucks. And yeah, there is this company called Blue River that uses ROS. And I'm not sure entirely if they use Gazebo, but they are doing agricultural robots using our tools. Yeah. So yeah, basically every field.
So
Yes.
these are
Oh,
the
sorry.
droids you're looking for.
Sorry?
So these are the droids you're looking for.
Ooh, the droids? I didn't get the joke, sorry.
Star Wars joke.
Oh, okay. Oh, sorry. I'm a bad nerd.
Agricultural robots and it's late on
How big's your current team right now? In the
This is it. This is all of us.
Oh, okay.
Yeah. This is all of us. So, and we all kind of have to work on everything a little bit to, depends on contractual obligations, but in general, we are kind of split in half people working on ROS and have people working on Gazebo. Now we're doing a lot of more cloud stuff too.
I think I missed. Where is the money coming from?
We have a lot of contracts with the government, so with agencies like NASA, NSF, DARPA, and we're working more and more with industry as well. So for example, Intel is just releasing one sensor, and it's ROS-based from the scratch, and they're partnering with us to make that happen.
And if they pay you to make some improvement, do they say this can be open source, or this has to be secret?
We tend to take projects that will make it open source, because we are in the role as the foundation to really cater for the community. So when we partnership with companies, we say, hey, we could do this closed source for you, but we would really prefer to do this open source and open it for the whole community. And they're usually okay with this. So, yes?
I was wondering if there is any simulation for atom or molecule scale projects. Because I think that would be useful in education because kids are really
Mm.
So if there's atoms or molecular reactions simulated in this way, it would be really straightforward and it would be really helpful.
Cool, cool. So the question is about like simulation of molecules and atoms, and this is not something that we focus with this simulator. It's really focused on the robotics use case, but I've heard of other simulators out there that do this. I don't know. I've never tried one of them, but it's not one of the use cases we focus on. Yeah.
So like MATLAB and Simulant, those are the
Yeah.
To her point about scale,
Mhm.
does this assume robots of like size of a car and smaller? Could I make transformer-sized robots, or could the physics not work at that size?
The physics in theory should work for most like human-sized, human scale, right? I've never seen anyone simulating a nano-robots. In general, I think big ones would be fine, but when you get really small, the numerical errors start to count a lot. So I can imagine that being a problem for the physics. Yeah, maybe if someone out there tries it, let us know how it went. Thank you.